Hello friends, it's Özkan Alpar here, and in this Godot tutorial I'm going to show you how to create a top-down shooter from scratch. We're going to create a player, we're going to create some enemies, we're going to be able to shoot the enemies using a raycast, and I'm also going to show you a bunch of other cool stuff as well. So there's a lot to do in this one, let's get to work. Okay, so the step one of our game here is going to be creating a new project. So let's go ahead and give it a very creative name, which is going to be top-down demo. I know, I'm very creative, so let's also find a folder for this. For me, it's going to be in the desktop. Let's see, inside of my documents, Godot version 4. And in here, I am going to create a new folder, which is going to be top-down demo. Let's say YouTube top-down demo, because I'm making this for YouTube. And besides that, we're not going to create a folder. We can just leave it as is and create it. So come on, you can do it. First step is going to be creating the main game scene that everything is going to take part in. We can call this the world, we can call this level 1, we can call it anything we want. In this case, I'm just gonna call this world actually, because maybe in this game there's like one big giant open world that everything takes place in. So to save this, we're going to create a new folder called scenes. Let's also create a folder called scripts and also one called assets. Let's save this scene by hitting Ctrl S inside of the scenes folder, just like that. And the first thing I want to do here is I want to create the background, which is going to be a green colored rectangle, just to represent some grass, like a foresty grass background. To do that, we could create a sprite and give it a tint, but we can also create a mesh instance 2D. And that way we don't need to use a texture. We can simply go into the mesh here, create a quad, and a quad is like this. So you can make it larger. It's white by default. I'm going to make it very large. I'm going to put it like that. And then I'm going to go into the visibility, modulate, and turn this into green. Like that. And I'm going to make it dark. Maybe even darker, less color, just like that. I think that's going to make a nice background. I'm also going to click on this lock icon here so that I don't accidentally click on it. As you can see, I'm not able to click on it because it's locked. Perfect. So let's run the game by hitting this. It's going to ask us to pick a main scene, which is going to be this one. So we can simply say select current. And we're just going to get this green background. Perfect. So the next step, I want to bring in the assets that I'm going to use for this. So I'm prepared some textures and some sound effects that I'm just gonna drag into Godot. The textures I drew myself a while ago for a game that I made for a game jam. So I'm just going to give these to you guys for free. But the sound effects I'm not going to be able to because I didn't make these. Okay, we might not use them anyways. We'll see. So okay, so that's the assets we have. We have a zombie, we have a top-down character, we have a gun, we have a bullet, which we're probably not going to use, and we have my masterpiece, the box. So, okay. So first of all, let's actually make the box, because that's going to be the simplest thing that we're going to create in this game. So let's create a new scene. Let's make this a static body. Let's give this a sprite. By the way, I'm hitting Ctrl A to open up the create new node dialog here. You can also just click on this plus here, which is going to do the same thing. And in here, I'm going to look for a collision shape 2D. And you can also like only type in C shape, and that's going to find collision shape. You don't have to type in the whole name, which is also kind of cool. Let's also create this. For the sprite, we're going to give it the box. Let's also rename this to be the box. Also save it into the scenes folder. Let's give it the sprite, the box. And by default, it's going to be too small. And also the pixel art is kind of blurred, as you can see. So to fix it, we're going to go into texture. We're going to go into the filter and set it to be nearest. And that's going to make the pixel art nice and crispy. There is a setting that we can change here, I think, which is like, where is it? Rendering textures, default texture filter, and we can set this to be nearest. And that will do it, I believe. But I think we had to do it before we imported the textures. Not sure. Whatever. So that's the box, but it's going to be too small for this game. So we either have to, let's actually create a box here. So click on the world, click on the instance button, and just select the box. And as you can see, it's tiny compared to how large the window is. So we're gonna have to either, let's see, I'm just gonna make everything larger. So that's gonna be my solution. So I'm just gonna take the sprite here, go into the transform and scale it by 3 so that it's much bigger. And then we're going to create the collision shape. And guess what? This is going to be a rectangle. So let's hold the edge here, hold down Alt as well so that we can scale it from the center. I'm going to make it just like that. Perfect. So let's save that. Let's go back into the world and let's maybe place down a couple of these. So while I have the box selected, I can just hit Control D and that's going to duplicate it. And then I can just move it. And by the way, I'm using the move tool here, which I can go into by hitting W. I was just using the select mode, which is Q. So I can switch between these using the shortcut. And when I'm in the move mode, I can just move stuff by clicking anywhere as long as I have it selected in the scene here. So yeah, just gonna create a couple more, just like that. Perfect, let's take a look at that. Obviously we can only see some of them, but we're gonna take care of that very soon. So that is the box completed. Yeah, we don't really need to do anything else for this. Next up, we're going to create the player. So let's create a new scene. The player is going to be a character body 2D. We're going to rename this to be a player. Save it inside of the scenes folder. We're going to create a script for this as well and save it in the scripts folder. But we'll get to this in just a second. Let's first create all of the nodes in the scene. So first of all, we're going to create a sprite 2D. And we're going to have multiple sprites actually. The first one is going to be the body. And then we're going to create one more, which is going to be the gun. So for the body, we're going to use the top-down character.png. And we're going to scale it up by like, let's say 3. And let's also give the gun its texture. And the gun will be scaled up because it's the child of the body. So it's fine. We don't need to do that ourselves. And that's looking good. Let's also create a collision shape. And the collision shape for the player, we can do a circle, but we can also do a capsule. Just going to fit nicely to the shape. And we don't really need to worry about the hands. They can just like not collide with stuff. It's fine. Okay, so perfect. Do we need anything else? We're going to have more stuff obviously, but for now we can just have those. So let's go into the world. Let's create a player. Let's put it in the center. I'm also going to go into the project settings, go into window settings. I want to make the window 1280 by 720, 16 by 9, I believe. Just because I want to do that. Okay, let's play this. Let's take a look at how the player looks. I think the size is just fine. We can leave it as it is. So the next step is going to be making the player move and also make the player rotate towards the mouse. Because we want to be able to, for example, if I'm holding the mouse here and I want to be able to shoot this box and the player needs to turn towards the mouse so that it's aligned. Otherwise, it's not going to make sense. So let's first take care of that because that's going to be very simple. we're simply going to create the process function, which is going to run each frame. And in this, we're going to use a function called lookAt. And we're going to look at the global mouse position. So there's also a function for that. So we're simply looking at the global position of the mouse. And that's going to look like this, which completely achieves what we want to do here. So we didn't have to do anything at all. We simply had to use the built-in functions Godot is providing. So it's always good when you can just rely on other people's work and you don't have to do it yourself. So feels good. Okay, so that's going to be the first step. The second step is going to be slightly more work. We want to make the player move. And the way I'm going to do that is I'm going to make him move by using the WASD keys. W and S, it's going to make it move up and down. A and D, left and right. Very simple. To be able to do that, first of all, we need to detect those key presses. And to be able to do that, we're going to go into the project settings, into input map, and we're going to create some input actions. The first one will be move up, then move down, then move right, then move left. Let's also create one for shooting and also to quit the game. So quit the game is going to be escape. Shoot is going to be the left mouse button. And then moving up is going to be W, down is going to be S, right is going to be D, and left is going to be A. You can also assign the arrow keys to these as well if you want to, but that's fine. Now we can use these in here, and I'm going to make the player move in the physics process instead of the regular process, because moving the player has to do with the physics engine. So we're going to do it here. And first of all, we need to detect which one of the keys we're pressing, W, A, S, and D. And to do that, we have a function called input. What was it? Get access. Yeah. And this is going to take in a negative action and a positive action. And if the negative action is pressed, it's going to return -1. If the positive action is pressed, it's going to return +1. And if neither or both are pressed, it's going to return 0. So we're going to use this function to determine which direction the player wants to go. So for the negative, we're going to say move left. And for the positive, we're going to say move right. And let's also print this to show you what it looks like. So by default, it's 0, as you can see. When I press A, it's -1. When I press D, it's +1. And when I press both, it's 0 again. So we can simply take this value here and multiply it with the velocity that we want to use. So when move left is pressed, the velocity is going to be negative on the x-axis, so we're going to move left. And when move right is pressed, we're going to multiply it by 1 this time, so it's going to be positive, so we're going to move right. So very simple, hopefully that's making sense. And we're going to do this again for moving up and moving down. Up is going to be negative and down is going to be positive, because up is actually in the y-axis, it goes negative. So that's the reason for that. And I'm going to save these two values in a vector called move direction. So the x value of that vector is going to be the horizontal movement direction, and the y value is going to be the vertical movement direction. Very simple. And then we're going to check if the move direction is not 0. So if it's not 0, then one of the keys are being pressed and we should move. But if it is 0, which is going to be this else statement here, we're going to make the player stop. And at the end of all of this, we're going to call move and slide to make the player actually move. But for this to work, we need to set the velocity. And we're going to do that here when one of the keys are being pressed. So we're going to say velocity equals speed which is a variable I'm going to create in just a second, times movement direction. Let's create speed up here. Let's set this to be something like, I don't know, 300. Okay, so that should be enough to make the player move. As you can see, by pressing W, A, S, and D, I'm able to move in all 4, actually 8 directions. But the problem is, when I let go, the player doesn't stop. So let's fix that. So to make the player stop, we're simply going to get the velocity.x, and we're going to set it to move toward velocity.x 0 delta. We're going to do the same for y, so simply switch velocity.x with velocity.y, and this is going to take in the current value of velocity.x. It's going to interpolate it down to 0 using delta. So if you want to learn how this works, you can hold down the control key, click on the function. That's going to take you to the description of the function, and then you can read this and learn more from it if you want to. You can also click this button to open it up in your web browser and potentially see more information, which is kind of cool. So with this, we should be able to stop now. Let's see. And indeed we can. Oh, actually no, we can't. Why is that? The reason is I messed up. This should have not been delta. Let's see how this works again. Delta. It says delta here, but it should be a larger number actually. That's why it didn't work. I'm just gonna make the speed. That should be fine. So now we can stop, as you can see. And it seems like we're kind of moving faster diagonally when we have both, let's say, S and D held down. And I think that's because the movement direction is larger than 0 in that case. So we can simply normalize it maybe. Let's say normalized. And that should take care of that. Okay, perfect. Now we have the player controller. Finally, I'm simply going to create a camera here so that we can actually see the different parts of the game. Just like that. Awesome. Hello friends, it's just Alpar here, and in this tutorial I'm going to show you how to create an enemy for a top-down shooter game, and also how to create an enemy AI that's going to be able to detect when the player enters its vision. So make sure to watch it until the end to understand how all of it works, and let me explain first of all roughly how we're going to implement this. So at the moment we have the player in the game, which looks something like this with his little gun, and we also have some boxes which are fantastic. As you saw, the art for them was amazing, and currently the world is peaceful, there's nothing going on, so we have to do something about that. We have to introduce some violence into this world, and we're going to do that by creating the enemy. That's going to be the first step. The enemy is going to be a zombie. It's going to have the usual stuff, the collision shapes and blah blah blah, the sprite, and it's going to have a couple of interesting mechanics. So the first one is going to be the vision. We're going to do that by creating an area 2D inside of the enemy, and it's going to have a circle collider like the one you see here. And if the player enters this collision shape, the enemy is going to start chasing the player. And if the player then exits it, the enemy is going to stop moving. So very simple mechanic. And this is going to make sure that if we have enemies far away, like here, they're not going to, all of them, they're not going to try to chase the player right away. They're going to wait until the player is in range. So that's the first mechanic of the enemy, very simple. The second one is going to be their ability to unalive the player. And we're going to do that in a very simple way. Simply, if the enemy touches the player is going to lose the game. And to do that, we're also going to create an area 2D in the player called the hitbox, which is going to be its purpose is going to be detecting if the enemy is touching it. And we're going to make that a separate collision shape because then we can control how big the hitbox is, which is going to influence how difficult the game is going to be. Okay, perfect. So that's about it. We're going to do a bunch of cool stuff like, let's see, calculating how far away the enemy is from the player, calculating the direction from the enemy to the player so that we can make the enemy move. So there's a bunch of cool stuff in this lecture, in this tutorial, so make sure to watch it until the end and let's get to work. So let's go ahead and start by creating the enemy scene, which is going to be a character body 2D, just like the player. We're going to call it the enemy and save it inside of the scenes folder. If you're planning on having multiple enemy types, it probably makes more sense to call this the zombie, and then you can have different named enemies. But in this case, we're just going to call it the enemy. Let's create a sprite here and also a collision shape 2D. For the sprite, we're going to use zombie.png, scale it up by 3, just like we did with the other sprites. So it's going to look like that. And we're going to create a capsule collision shape, just like the player, because they're very similar in how they look like. So maybe something like that. Perfect. And now we're going to create the area 2D that's going to detect the player. We're going to call this the player detector. It's going to have its own collision shape, which is going to be a circle. And we're going to make it large like that. So the bigger this is, the more vision the zombie has. And this way, the zombie is going to know even if you're behind the zombie. So you might want to turn this into actually like a polygon if you want to. That way you can create like a triangle in front of the zombie, and then you can basically sneak past the zombie if you're behind of it. But this is the way I want to do it. My zombies are slightly more intelligent, I guess. So they know if there's something behind them. So that's how that's going to look like. Let's go into the world and put one of these just to see what they look like. And we can actually go into the debug menu here and turn on visible collision shapes. That way we can actually test this a little bit easier. Okay. As you can see, that's what that looks like. Perfect. And I also want to go into the player script real quick, and I want to make it so that when I press the quit input action, I want the game to stop. So I'll just do that real quick. Just like that. Just a quality of life thing for me. And then we're going to actually go into the player scene again, and we're going to create the hitbox for the player, which is going to be an area 2D. Let's call it the hitbox. It's going to have a collision shape. And if the enemy touches this collision shape, we're going to lose the game or lose a hit point or something like that. And this is going to be a capsule again. And the larger this is, easier it's going to be for the enemy to hit the player. So it's going to control the game difficulty in a sense. So up to you. I'm just going to make it slightly smaller than the collision shape of the player. But that's going to bring up a problem. How is the enemy going to touch the hitbox if the collision shape of the player is larger? So we can actually connect the body entered signal of the player, of the hitbox to the player script. So let's just double click on it. Connect it. And then here we can just print touched the player. If we play the game, let's see, something touched the player. That wasn't the enemy though, so don't worry. As you can see, the enemy can't touch the hitbox because we're colliding with the enemy. So we need to determine in our game what collides with what. And to do that, we can use the 2D physics layer system, which I'm going to explain briefly. I'm not going to get too detailed with it. So if you click on any collision shape, like any physics body here, you will see that it has a collision tab. And in here you have layers and masks. Let's say that this is on layer 1 and it's looking for the mask is also layer 1. So we are on layer 1 and we're looking for other, physics bodies or areas to collide with that are on layer 1 as well. If you put this to be layer 2, the mask, now we're looking for things to collide with on the second layer. So if there's something on the first one, we're not going to collide with it. And we're going to have multiples of these as well. We're going to, we can be on layer 1, 2, and 3, and we can look for collisions with 3, 4, and 5. Okay, so we can use this system to determine which object collides with what, basically. And we're going to give these names to make that a little bit easier. So let's go into the project settings, into 2D physics, and in here we can name these layers. So the first one is going to be the world or the environment. So this is going to be anything like the boxes we have, any other objects like a prop that we might place down. It's going to be on the first layer. The second one is going to be the player. The third one is going to be the player's hitbox. After that, we're going to have the enemy. The enemy is not going to have a hitbox. We could create a hitbox for it, but we can get away with not having one. So I'm just going to do the easier thing here. And then we're going to have the enemy's player detector. So we have all these different types of objects, and now we're going to determine how they interact with each other using the layer system. So for example, for the hitbox of the player, we're going to place it on layer 3, as you can see, which is the player hitbox. And the player hitbox is simply going to check for collisions with the enemy. That's it. So we're going to have the mask set to be 4. Let's do it for the player as well. So click on the root node, the character body, go into the collision, and there's 2 of them here. So the one in the bottom is going to be the right one. So the player will be on the second layer, and it's going to look for collisions with the environment and also with the enemy as well. Let's see. And also the enemy player detector. We'll also try to check with that as well. Okay. So let's go into the box, for example. And the box is going to be on layer 1. It's part of the environment. And it's going to check for, let's see, with the player and with the enemy. Yeah, that's going to be all for the box. And for the enemy, we have the enemy itself, which is going to be on layer 4. And this one is the collision shape of the enemy, right? So we don't want this to collide with the player. We want this to collide with the environment, and let's see, anything else. Other enemies, yeah, why not, maybe. Okay, that's going to be all. And for the player detector, it's going to be layer 5, and this will check for the player only. Okay, did I do all of that correctly? Hopefully. So the player here actually is not going to collide with the enemy. I made a mistake here, so go into the player, and for the root node, make sure it doesn't collide with the enemy. Because that's the problem we're fixing. Remember, the collision shape of the player is too big. So if we're colliding with the enemy is not going to be able to touch the hitbox. Okay, perfect. So now we should be able to play the game. And as you can see, the enemy can touch the player. Perfect. Okay, so that fixes that problem. And we'll obviously want to check in here if this is actually the enemy, because it might be something else. So to be able to do that, we can actually just go into the enemy. We can create a script. Let's create the script. And in the script, we can use a class name keyword and give this class a name, which is going to be enemy. When you use this keyword, now you can use this enemy keyword here as a type to check if a variable is of this type or not. Let me show you how to do that. So in the player, we can say if body is enemy. only then print this. So body here is what the hitbox collided with. It's a physics body, but we don't know if it's the enemy yet. So that's why we do this check. And if this if statement is true, then it's definitely an enemy. So now it's going to look exactly the same. But now we know for a fact that it's the enemy. So if we were to touch other stuff, if we had other stuff that we could touch, it wouldn't say touch the player. And obviously here we don't want to say just touch the player. What we can do for now is we can basically, let's actually emit a signal. I'm going kind of out of order with this lecture. I meant to do the enemy first, but I'm doing all this stuff, but it's okay. It's gonna come together as we continue. Just trust me. So we'll create a signal called died, and we'll just emit the signal here. We'll say died.emit. And we can also queue free the player. So we'll just get rid of the player. And in the world, then what we can do, we can create a script for the world. And in here, we'll just take a reference to the player. And in ready, we'll just, let's see, that's going to be lowercase. We'll just connect the died signal to a function here. Let's call that onPlayerDied. And in here, we can just print game over. And then we'll restart the game, which we can do by calling getTree reload current scene. But we don't want to do it immediately. We want to do it after a delay. So we'll just say getTree again, create a timer for 3 seconds. And let's take the timeout signal of that timer and let's connect it to this function right here. So make sure to get rid of the parentheses at the end there, just like I did. We're simply taking the timeout signal of the timer that we created just now and telling it to call reload current scene after the timer is timed out. Okay, hopefully that's all making sense. So now the enemy should be able to kill the player. Let's see. As you can see, the player goes away, it says game over, and in 3 seconds, we're back, baby, we can play again. But as you can see, there's a slight issue with this, and that is when the player gets deleted, the camera is also deleted. So we have to fix that as well. And we're going to do that using a camera, a remote transform for the camera. So go into the player and create a remote transform 2D. And this is a very simple node that takes its own transform, its own position, and pushes it to a different node. And you can specify what that node is. So in this case, it's going to be a camera that's in the world scene. And that camera is going to take its position from the player's remote transform. So even if the player gets deleted, the camera won't be deleted, it will still be in the world scene. So we'll just call this the camera remote transform. And as you can see, it has a remote path. This will be the path to the camera node, and we're going to set this from the world script. Before we do that, in the player script, we'll just create a reference to this. Let's say onReadyVar camera remote transform. Just like that. And then we can go into the world script here and use that. So we're going to, let's say, we're going to create a camera here in the world, and we'll call this the main camera. And then we're going to create a reference to it, probably. Main camera. Just like that. And after we connect the signal, we can just say player camera remote transform dot remote path. So remote path is going to be this property here that we need to set. So that's going to be the main camera.get path. So this is going to make sure that the camera we have here in the world, which is right here, it's going to get its position from the remote transform node in the player. And that's going to create the same effect we had. So the camera is going to be on top of the player exactly. But now, if the player gets deleted, the camera is still there. Because if you take a look at the remote tab here, you'll see that the camera is here in the world. Let's see, where is the game? Here it is. Okay. And if I lose, you'll see that the camera is still there, but the player just got deleted. So that's how that works. Hopefully this is all making sense. We did everything besides working on the enemy up until now. So next up, let's make it so that the enemy actually moves towards the player when the player is inside of the player detector. And also, we're going to do a bunch of other cool stuff as well. So let's get started with that. Okay, so the way the enemy is going to work is going to be similar to the player in terms of its movement. Let's also create the process function. Okay, and let's also connect the player detector's signals. The first one being body entered, and the second one being body exited. So in the body entered function, we're going to detect if it was the player that entered the player detector. And in the exited, we're going to determine if it was the player that exited. And in both cases, we're going to set the player variable, which is going to be up here. So this is very important for the enemy because the enemy needs to know where the player is to do anything, basically. So we're going to create a variable to store the player. And I'm going to go into the player script and use a class name here as well, because we're going to have to do something similar. We're going to have to check if something is the player or not. So we can also say that this player variable can only be a player type. So that's how you do that in Godot. You put a colon, you give the type. So now this variable can only be set to be a player, nothing else. You can also do it with like an integer, you know, with like a float, whatever. In this case, it's going to be a player. Okay, so first of all, let's do the detection. So if something enters, a physics body enters the player detector, first we'll check if that's a player or not, and if the player variable is null. If both of those are true, we can go ahead and set the player variable to be the body, which is the thing that we collided with. And we can just print something here, and we can say name plus found the player. Name here is the name of the enemy, found the player. Very simple. And we can do something very similar down here. If something exited the player detector, was that the player? Is the player not null? So do we have a player at the moment? If so, the player just left the detector. So let's just say it's null now, and name lost the player. Okay, so this should be working. So let's give this a try. Now I should be able to enter here, and enemy will say enemy found a player, and when I get out, enemy lost a player. Perfect, it's working. So the next step is going to be making the enemy face the player. And we can do that using the lookat function that we used in the player. So in the enemy, in the process, we'll simply say lookat the player global position. But there's an important check we need to make. Do we have a player? So if player is not null, only then we'll try to look at it, because if it's null, then we're going to try to get the position of something null, and that's going to crash the game. So very important that you do this check. Now the enemy should be facing the player, and as you can see, it is. Perfect, we're almost there. The next step is going to be making the enemy chase the player. And to do that, we're going to do a couple of interesting stuff. So first of all, let's say this is the player, this is the enemy, and the player is in the range, so the enemy wants to chase the player. First of all, the enemy needs the direction to the player. And to do that, we can simply, let's see, we have the enemy's position here and we have the player's position here. So to find the direction, to find a vector that's going to look like this, a vector that starts at the enemy's position and goes to the player's position, we can simply take the player's position, PP, and we can subtract the enemy's position from it. And that's going to give us this vector right here. And then we can normalize that, and that's simply going to give us the direction. And then we can multiply that with speed to make the enemy move towards the player at the speed that we want. And one other important thing that we're going to check here is going to be the length of this vector. Because we don't want the enemy to try to go inside of the player. We just want it to get close enough to touch the player and stop. So we're also going to check how big, how long this vector is and stop the enemy if it's getting too close to the player. Okay, so let's implement that. So first of all, I'm going to create some variables up here. Let's say speed. We can make this a float, just like that. And we can set this to be 100 so that it's slower than the player. I'm also going to create the direction here, which is going to be a vector 2. And there's a shortcut for this, by the way. You can just say colon equals, and then it will just infer the type. So if you give it a vector 2, for example, now this variable can only be a vector 2. Okay, so that's the direction, that's the speed. So we're going to use these in physics process. And physics process is going to look similar to what we did for the player, at least the second part, this part right here. And the first part, the direction is going to be different. It's going to be what I just explained to you, because obviously we can't get the direction from the keyboard this time. We need to calculate it ourselves. Go ahead and change the move there here to direction. And we don't have to normalize it here. We're going to do that somewhere else. But besides that, it's going to look the same, just like this. Perfect. So let's get the direction, and let's also do the calculating of the length of it as well. So first of all, before we do that, actually, let's make sure that we have the player. So if the player is not null, only then we'll try to move. Next up, we're going to find that vector from the enemy's position to the player's position. We can call that enemy to player, just like that. And that's going to be player.global position minus global position of us. And then we can actually check, let's see, we'll do the length later. Then we can simply say direction equals enemy to player.normalized. And with this, the enemy should be moving towards the player. Let's give it a go. And it is working, as you can see. Obviously, it's not very smart, it's kind of dumb, so it's not going to be able to get over like a box like that, but that's something we can fix later, step by step. But as you can see, it's working, and if I get out, it's going to stop. Get in, get out, get in, get out. Perfect. But the problem is going to be, well, now there's no problem because we die in one hit, but if we were not dying in one hit, let's actually stop the player from losing the game. And let's see, pass. Okay. You will see that the enemy just tries to get alarmingly close to the player, and it goes into a crazy rage like that. So to prevent that from happening, what we're going to do is, before giving the direction to the player, we're going to check the distance between the enemy to the player. And to do that, we can simply say enemy to player, which is this vector right here from the enemy to the player, like I said. And we can just say dot length. And that's going to give us a float like 50 or 80 or 100. And that's the distance. And we can check that. So we can say if enemy to player dot length is let's say, greater than 50. Only in that case, set the direction to what it's supposed to be, and else we can say direction is 0. So we can actually make it even larger to see the effect easier. Now, as you can see, the enemy tries to get close, but if it's closer than 100, it stops. But of course 100 is too much. It's never going to be able to touch the player. So it probably needs to be like 20. And what I'll do is I'll just turn this into a variable. So we'll just say stop distance. And we'll set this up here to 20, which should be good enough. Yeah, that's good enough to touch, probably. Let's turn it on. Yeah, that's good enough. Okay, perfect. And now the game is going to restart as well. Awesome, so we have an enemy that follows us when we get inside of their range. And they actually stop without getting too close to us, and they can touch us and they can make us lose the game. So perfect. Awesome.
Hello friends, it's Iskan here, and in this tutorial I'm going to show you how to create a very simple, very easy to create shooting mechanic using a raycast 2D node. So there's a bunch of cool stuff to cover in this one. Let's get started with the explanation.
So first of all, as usual, I'm going to explain how this works in theory using my painting app here, and then we're going to switch over to Godot and implement this. A good challenge for you is going to be watch the explanation or listen to the explanation that I'm going to give now, and then go into Godot and try to implement this yourself, because that way you can actually improve your skills instead of just watching me do it and then follow along blindly. And that's the real game development skill that I want you to achieve here, not just following tutorials. So listen to it. If you haven't seen the previous tutorials, also take a look at those as well. I'll have them in the description probably. And then, like I said, give it a go. If you can't do it, it's all fine. You can just come back and watch it. But yeah, that's going to be important. So with that being said, today we're going to implement shooting the enemy. And let me explain how that's going to work. So in shooter games, usually there's two different ways of implementing a gun. The first way is using a projectile, which is going to be a game object that we spawn. It's an actual object in the game. We're going to spawn it at the tip of the gun usually, and then we're going to launch it. So it's an actual object with a collision shape, a sprite, a script probably, and that's going in a certain direction. And once it hits the enemy, it's going to hurt the enemy. And usually, since these are actual objects traveling through the game, you can dodge them. So if the projectile isn't very fast, the enemy might be able to dodge it, or the player might be able to dodge it as well. So it has its advantages, it has its downsides. It really depends on what you want to do. So that's the first type. Usually in games, if you have like a rocket launcher, it usually has a projectile, for example. And then the second type is going to be a raycast. And a raycast is a very simple concept. It's a technique that you can use. And in Godot, there's a node called raycast 2D. If you want to do a 2D raycast, there's also a 3D version as well. And the way we use this is we give it a starting point, which is going to be the tip of the gun. And then we give it a length. So let's say it's this, the length is this. Once you activate the raycast, it's going to check if anything is colliding with it. So in this case, this enemy, for example. And if we had stuff behind the enemy, for example, if we had a box here and maybe another enemy here, and if the raycast was, long enough, it could, collide with all of these. But we only want the first one. And to get that, there's a function called getCollider that we can use, which is going to give us the first object the raycast collided with. So that's basically how a raycast works. And this, like the difference between this and the projectile is that the raycast is instant. The second, the millisecond, probably the nanosecond you activate the raycast, it's going to hit the enemy, just like that. So like the enemy is not going to be able to dodge it. No one is going to be able to dodge this if the gun aligns with the enemy. So it's going to give a more like responsive instant hit, probably closer to like a real life gun, because in real life, even though in real life it's a real projectile moving through space, it's so fast, it's instant, right? You can't see the bullet, in real world when someone fires a gun. The raycast gives a similar feeling. You shoot something, they get hit instantly. And there's, in the case of the game, there's no projectile, there's no, collision shape, traveling through space, nothing, instant hit. And it's just going to give a different feel. Games like Counter-Strike, for example, use raycasts. So when you shoot someone in Counter-Strike, it's an instant hit. And even though they have like a visual effect that plays as well, so sometimes you can actually see bullets flying through, like while playing Counter-Strike, but those are completely visual. Those bullets don't actually do anything. They simply do a raycast, and at the same time, they play like an animation of a bullet. But it's the raycast that does, the detection or the damage. So that's the shooting part. We're going to do a little bit more. Mainly, let's see, we're going to make the enemy follow the player once it's shot, even if the player is outside of the range of the enemy. Important thing, because the enemy isn't that dumb, right? If they get shot, they're gonna know. And we're also going to play sound effects. I actually took some notes here. Let's take a look. Because I'm doing this off the cuff, I don't want to get lost. So raycast and the shoot sound, I'm actually do that last. Let's see. Raycast, shooting logic. The enemy is going to take damage, so we're going to create like hit points for the enemy and all that stuff. And then the enemy is going to follow the player after getting shot. And then we're going to create some sound effects. And the sound effects are going to be a game changer. Like when we implement the shooting, it's going to look cool. But until we add in the sound effects, it's going to feel kind of like dead. It's not going to feel very juicy. The game feel isn't going to be there. But once we add some sound effects, oh man, it's going to be much different. So make sure to stick around until the end to see the difference. And like, it's going to make a big difference. I actually forgot to add something here. I also want to shoot the player, take the damage, and also enemy shot animation. So we're going to play a little animation as well when the enemy is shot. Okay, so that's all I want to achieve. So let's switch over to Godot and start implementing this. Okay, first of all, let me take a look at my notes here. So first of all, obviously, we're going to create the raycast in the player. So let's go into the player. Let's create a new node. This is going to be a raycast 2D. We can rename this to be something like shoot raycast or something. And then we're going to place this at the tip of the gun. So just at the tip. And as you can see, currently it's looking downwards. And if you go into the inspector, you can see that that has to do with the target position. Currently, the target position is 0 on the X and 50 on the Y. So we need to set the Y to be 0 and then X to be something positive, like 100. If you set it to be negative, it will look left. So we want it to be positive. And the length of this is going to determine how far the player can shoot. And I'm just going to make it something kind of arbitrary, like 1,000. Like that maybe. Yeah, that seems good enough. Yeah, I don't want to shoot things that are very far off into the distance, like, because this is going to be like an open world game. I don't want to shoot things very far away. So I'm just going to keep it at 1,000, but this is something we would test and iterate over and over again as we make the game. You can see that there's a collision mask here. So we're going to look for the environment and also the enemy. We need to check for the environment as well, because if there's a box in front of us and there's an enemy behind the box, we want to be able to check for the box as well, because we don't want to shoot the enemy that's behind the box. So that's why we're also going to check for the environment. And collide with is also going to be kind of important. Yeah, let's say we also collide with areas, although it doesn't really matter. We'll just turn it on. Let's see. What else do we need here? It seems like that's all we need. So we have the raycast, it's this long. Now we're gonna go into the script and actually use it. And in terms of the input, I believe we created a shoot action, which is the left mouse button. Good. So let's go into the script. Let's do this in the process function. It seems to be a good place to do this. So first of all, we'll just check if input is action just pressed, shoot. We'll just print something to test that it's working. So when we press the mouse button, we print shoot. Okay, good. So first of all, let's actually create a reference for the raycast. Shoot raycast, shoot raycast. And like I said, the raycast is going to have get collider. And this, if you control click on it, you can read the description, returns the first object that the ray intersects, or null if no object is intersecting the ray. And we can also do is colliding, actually, to check if something is colliding or not as well, first of all, before that. So what I'll do is I'll just say if shoot raycast is colliding. If we're colliding with something, when we press shoot, then we can get the collider. Let's say collider. And now we have the first thing that the raycast collided with. Next up, we're simply going to check what this is, because it might be a box, it might be the enemy, and it might be something else that we added into the game. Thankfully, there's a very easy way to check if this is an enemy or not. We can simply say if collider is enemy. And I can even do if collider is static body 2D. And then I'll just turn this to an else if. So if it's a static body 2D at this point in the game, it's basically guaranteed to be a box. So shot a box. And then if we shoot the enemy, we'll just say print shot the enemy. Good job. Okay, so let's test this out. Let's see, so if I shoot a box, shot a box, and if I'm shooting nothing, let's see, there's a box there as well. Okay, if I'm shooting nothing, not printing anything, if I shoot a box, it's printing shot a box, and if I shoot this guy, it says shot the enemy. As you can see, it's working. And if I try to shoot him like this, it says shot a box. Exactly what we want. Perfect. Next up, now that we can detect that we're shooting the enemy, we can actually implement the enemy's health and the enemy's take damage function. Okay, so actually here, let's say collider, let's actually create an enemy variable and say collider as enemy. This is a cast. So it's basically going to take the collider and it's going to turn it into an enemy, because that's what it is, so that we can get some auto completion with the functions inside of the enemy class, basically. So for example, what do we have here that we created ourselves? Nothing right now. So let's say take damage amount, that will be an integer. If you go back into the player script, now we can say e.take damage, and you can see there's like auto completion. Whereas if you just said collider.take damage, it shouldn't really work, but I guess it actually works, and that's because we have this here. So Godot is smart, so it's actually filling in the blanks for us. But if I just try to do it here, for example, it's not going to give me any auto completion, as you can see. It's actually giving me nothing, because at this point, since this is an interpreted language, it's not really clear what this is just yet. Like, it's whatever get collider returns, we don't know. But if you do this check here, if collider is enemy. In this if statement here, it's guaranteed that this is an enemy. So that's why we can actually just use the take damage and get the autocomplete. Small tangent, but I think it's cool. So we actually don't even need this. We can just say collider.take damage because of the if statement. But if you just wanted to do something here without doing an if statement and you knew it was an enemy, then you can use as, I guess, enemy, just like that. And then you can get the autocomplete. Cool. So yeah, we'll just say take damage and we'll just damage by 1. You can turn this into a variable in the player. For example, like how much the player's gun hurts the player, that would be the variable. You can have different guns, for example, and so you can pass different values depending on which gun the player is using. You can have power-ups. Once you take them, the damage increases. You can do tons of stuff with this basic system. Like you can take this and use it as like a framework and create something cooler. But for now, we'll just say 1. And in the enemy, we want the enemy to take damage. So we'll create a variable up here called hit points. This will be an integer. We'll set it to be 3 at the start. So it will take 3 hits to kill the enemy. And then, let's see. In take damage, we'll first check if the amount that we passed is greater than 0. Otherwise, it's pointless. If it is, we'll say hit points minus equals amount. So we deduct whatever damage from the enemy's hit points. And after that, we should also play like enemy hurt sound, play enemy hurt sound. And after that, we basically need to check if the hit points are 0 or less. In that case, the enemy is gone. So we'll say if hit points less than or equal to 0, print enemy died, and Q3. Maybe we can just print the name. Yeah, this should basically kill the enemy. Hit points 3. Okay, so let's see. In the player, yeah, everything should be working. Let's give it a shot. 1, let's see, are we printing? 2, 3. Yes, as you can see, I clicked 3 times. You probably didn't hear it because my mouse is very silent, but clicked 3 times and the enemy died, basically. Yeah, so that's what we want to achieve. So that is the raycast, and that's also the shooting logic and the take damage in the enemy. And then, we have the animation, which is going to start juicing this up, because as you can tell, currently it looks like kind of shit. So let's make this look a little bit nicer. So to create that effect, we're going to create an animation player in the enemy. And we're going to create an animation called take damage. We'll set this to be like 0.3 seconds. It has to be very quick. And let's get closer. And we're simply going to change the sprite's modulate to red so that it has a red tint to represent that it's being hurt. And then we're going to interpolate that back into the original color of the sprite. So let me actually turn off these collision shapes so that we can see it. And while I have the animation player selected and the animation open, I'm going to click on the sprite. And then I'm going to go into visibility. And we have this modulate here, which basically gives it a tint, as you can see. And we can pick any color that we want, but red is going to be for blood. So that will be red. And then what we can do is we can set it to be completely red, just like that. And then we can key that by clicking on this button and click on create. And then at the end of the animation, we'll set this back to be white. And key again. Make sure to key or else it's not going to work. And as you can see now, Godot has created the in-between frames to shift the color from red to white. and you can click on this button to see it in action. So very simple effect that you can create using the sprites modulate property, but it works and looks good. And there's also a reset here, which is red, so this should be white. So just pick the reset animation here, reset the modulate, and click on key again. Godot just creates this to reset things, I guess. So yeah, by default we'll just keep it at reset, but the next step is going to be using the take damage function, the animation from our script. Let's create a reference up here to the animation player, anim player. And then when we take damage, we'll play it. Anim player.play, take damage, just like that. Let's try. And as you can see, now it's looking much nicer and you can actually see that I'm shooting it. Feedback, that's important in games. Like once you do something, you shoot something, you pick something up, you pick a power up, always you need feedback to give to the player in terms of like visuals, animation, sound effects. That's what makes the game feel enjoyable. Okay, so that's great. Let's see, what's next? I like this note. I never do this, but it helps, keep the composure. So the animation enemy is going to follow, and then finally we have the sound effects, which is going to be awesome. So, okay, that's going to be very simple. See if you can do this by yourself, by the way. It's just going to be a single line of code. So in the enemy, we have the player, and once the player is found, this is going to kick in and follow the player. So if we want the enemy to follow the player, we simply set this variable to the player. That's it. And this, we could also just call this the target actually, and then we can have enemy follow anything. It can be more general than just the player. Okay, so in the player, we can do it here. We can do it in take damage, but doing it here is going to be easier. After we take damage, we can say, actually before we can say collider.player equals self. Self is going to represent this object, which is going to be the player. So we're giving the enemy ourself to follow, basically. Now we can shoot the enemy, and the enemy will follow us. And the downside of this is they will never stop following us with this, because we made them follow us outside of the collision shape. So I can get in the collision shape and get out again, and then they'll stop. But if I shoot them here and I maintain the distance, even if I go very far, they will still continue. So that's a bug that you can fix if you want. We can set like a timer here, and then stop chasing if the timer goes out. Easy solution right there. Just thought of it at the top of my mind. So if you want to do that. It's a cool idea. But finally, what we're going to do is the sound effects. So there's going to be two. First one will be in the player, which will be an audio stream player. It can be a 2D one, doesn't really matter. We'll call this the shoot sound or shoot SFX. We'll just say sound. It's going to have, let's go into the sound effects, the gunshot. There's a gunshot and a short one. I think I want to use the normal one. And then, let's see, anything else do I want to change here? Not really. Yeah, that will be it. And then we'll also do the same in the enemy. And this will be the hurt sound, which will be zombie hurt. And those will be the only ones I implement in this lecture. So very straightforward. Let's first of all do this one by one. I'll create a reference here. Let's do the shoot sound first. So this will be in here. So after we shoot, we can just say shoot sound dot play. Now this is going to be somewhat problematic because if I play the sound, it's going to come out of my speakers and it's going to go into my microphone. So it's going to sound horrible. So that's why I'm going to actually turn off the sound of my computer. Set it to be 0. And then I'll play the game. But I'm not going to be able to hear it. But will you be able to hear it? You should be able to hear it. Let's see. Boom. I can't hear it. I hope you can. Let me actually turn it up a little. You know what I'll do? I'll actually, just to make sure that you can hear this, I'll actually use my trusty earbuds. And then I'll switch my, did I type something? No, okay. Sound source to them. Hey, just Khan from the future here. At this point, since I switched to my earbuds, like I stopped recording the sound that's coming from the game, unfortunately. So after this point in the video, you're not going to be able to hear the sound effects, but let me just show you how it, ends up sounding like. And, you're just going to have to go through the video like that. So in the end, it's like this. Okay, as you can see, it's very cool. It's a night and day difference between without sound effects and with sound effects. So with that being said, let's get back into the video. Okay, cool. And then I'll play the game. And now everything should be just fine. And as you can see, just that sound effect makes things so much different. Like shooting actually feels fun now with the sound. Otherwise, it just feels like bland, emotionless. And let's see, I'm actually gonna put more enemies. Just Control D to duplicate and just like put a few of them into the area, just like that. And now when I shoot them, even if they're like far away, they're gonna start chasing me. And I just realized I'm only playing the sound when I'm shooting the enemy, so that's not gonna be good. And that's because, let's see. Should be playing all the time. Oh, it's only when it's colliding, so yeah, duh, okay. Yeah, now it plays all the time, perfect. Obviously you can shoot very fast. You can introduce like a cooldown mechanic. That's something we can do later. If I do all of these things, it's just gonna make the tutorial like 2 hours long, so just gonna keep it a little bit shorter. So next up, let's do the hurt sound. Hurt sound. And then we'll just play this here. What am I doing? Hurt sound, play. Perfect. Now it feels much better. It feels like we're actually hurting, the enemy and making a difference in the game world instead of being boring. Okay, so that's it. Yeah, that's all the list. So in this one, what we did is to do a small recap for you guys. We created a raycast 2D in the player. We set the collision to be the environment and the enemy layer, and then we made it 1000 pixels long on the x-axis. So you can play with this to create different types of guns. Maybe you have like a sniper rifle that can shoot very far away, and maybe you have like a pistol that can only shoot very little distance, blah blah blah. You can think of that as well. So that's the raycast, and after that we went into the script and we created this little if statement here, which is first of all checking if we pressed the left mouse button. If so, play the sound effect, and after that check if the raycast is currently colliding with anything or not. If yes, we get the first object that we're colliding with. Let's see, is it an object? It's an object. Okay, Get out of my way, Windows. Ruining my tutorial. Windows, come on. Have some manners. Yeah, we get it as an object. And then we store it in this variable, and then we check if it's a static body 2D, that's going to be a box, because that's the only static body 2D we have in the game. Else, if it's an enemy, then we can hurt it and then set ourselves as its player so that it starts chasing us. So that's what we did here. And then in the enemy, we created a variable to keep track of the health of the enemy, which we set to be 3 at the start. And then we created the take damage function, which is going to deduct the amount that was passed from the hit points, play the hurt sound, play the animation, and if the hit points reach 0 or less, we basically delete the enemy. And in the end, I just explained it, but yeah, we also created the animation. Let's also take a look at that real quick. So we created an animation player, and what we did was we created a very short animation which animates the modulate property of the sprite to be red, completely red at the start, and then at the end it's white again, which is going to turn it back into its original color. So that was the animation, and then finally we also created the sound effects so that we have some game feel, game feel, basically. And obviously we also made the enemy follow the player when shot by setting this. Hello friends, it's just Khan here, and in this tutorial I'm going to show you how to create a laser effect in Godot for a top-down shooter game. So let's start with the explanation. So first of all, of course, we have the player here on the left-hand side. The player has the gun, and we have an enemy here, or we have like a box or something else that we placed inside of the game. The effect that we're trying to create is a laser that's going to start at the tip of the player's gun, and it's going to extend until it hits either an enemy, a box, anything with like a collision shape that we can detect. So that's the effect. How are we going to create this? First of all, for the visuals, we can simply use Align 2D, which is a node that we can use that can draw a 2D line onto the screen. Very straightforward, extremely simple. We're going to give it some points. The first point is going to be here, and the second point is going to be, in this case, here. And it's simply going to draw a line in between those 2 points. But the problem here is the line 2D doesn't really know anything about this world. It doesn't have physics, it doesn't have collision, it doesn't know where to stop. So we need to provide that information to line 2D. And to do that, we can use a raycast. And the raycast is going to go from the player's gun into the game, just like that. And then the raycast is going to give us this point right here using the get collision point function. So for example, if we were casting the raycast here, it would give us this point in world position. So for example, this might be 100 by 200, right? And then we would give this to the line 2D, and then line 2D would draw a line from the tip of the player's gun until that point, and then stop there. That's what we're going to do in order to set the line's length dynamically to what it's supposed to be. And in the case that we're not hitting anything with the laser, so for example, if the gun is here, and then the laser is just going to go like that, and there's nothing in the path, we're simply going to make it long enough so that it goes outside of the screen, so that it gives the illusion of the line going really deep into the game. So that's how we're going to achieve all of this. Okay, so that's the basic explanation. Let's go into Godot and start working on this. So let's go into the world and let's actually play the game and see what it looks like right now. As you can see, we have the player, we have the enemies that follow the player. We can shoot the enemies. Whoops, I'm gonna turn my sound off so that I don't capture it with my microphone. But as you can see, we have the game. If you haven't seen how I did all of this, there's a link in the description to the playlist where you can get the tutorials to create this exact game, if that's what you want to do. But in this one, like I said, we're simply going to create the line effect so that we can see exactly where we're pointing, because actually we're not going to have the mouse cursor in the game in the long term. So we want to know if we're hitting the enemy or not. Okay, so let's go into the player and let's create a line 2D node. And we can simply call this laser line 2D. Okay, and as soon as you select a line 2D, you will see a set of tools up here. The first one is used to create a point. So while you have it selected, you can click on any location and create a point for the line. The second one is used to move these points so that you can make adjustments. And the third one is used to delete them. Just like that. So we're not going to use these because you can also do this manually from the inspector using the points property here. You can simply click on it and you can create the elements that you want. In this case, we want 1 point at the start of the gun and 1 at the, a little bit further on the x-axis. So the first one is going to be the tip of the gun. Let's say 60 for that. And the second one is going to be something like 1,000. Just like that. And we're going to set this from the script, obviously. So this is just for us to see it while we work on it. It's not going to be the final value. As you can see, whoops. If you create something by accident like me, you can simply delete it like that. Okay. So as you can see, that's what the line looks like. Currently it's white and it's too thick. So we're simply going to click on it, change the default color to be red. And I'm also going to decrease the alpha so that it's a little bit transparent, which is, I think it's going to look good. And then we can also change the width to be something like 2. That should be good looking enough. And now, as you can see, it's kind of over the gun, which is, I don't want it to be that way. So I'm simply going to take it in the scene hierarchy and put it behind the body and the gun, just like that. Okay, and we can kind of turn off the raycast maybe. Okay, it's kind of difficult to see, but it's there. Yeah, so that's basically what we want to do here. There's a bunch of different options we can change here. We can give it a gradient, we can use a texture, we can change the caps. Caps are the ends here. For example, we can make the end round instead of just being like a box. And there's like a border you can create. There's a bunch of things you can play here. So feel free to give that a go, but we're going to continue with this and actually implement the functionality of the laser. Because at the moment, it will be visible, but as you can see, it's just being drawn all over the place. It's not stopping when it touches an object. Okay, so to achieve that, let's go into the player in here. Let's create a reference to this. We'll just say laser line 2D, just like that. And what we can do is in process, we can first check if the raycast is colliding. I can also do, like, we're gonna have 2 similar if statements. We can do them in one if statement if we want to, but I'm gonna keep things separate and clean. So that's why I'm going to create it up here as well. So if the raycast is colliding, we can ask for the collision point. So before we were asking for the collision object. Now we're specifically going to ask the point that the raycast is colliding. We can do that by saying shoot raycast get collision point and save it in a variable called CP collision point. And if you control click on this, you'll see that it's going to return a vector 2. Okay? And let's actually try to print this and see if it's working. You can see that while I'm pointing to an object, I'm getting a position. And if I'm just pointing into nothing, you will see that it's not really printing anything. But if I am you'll see that we'll get that point. Okay. Now you might just think you can take this collision point and set it to be the laser's second point here, but it's not going to work that way. And that's because that collision point is in world space. So it's the position in the entire world. But these laser positions here, the points, as you can see, it's 60 by 0, 1000 by 0. These are local to the player. These are in this player scene. So we need to take the world position, the collision point, and turn it into the local, coordinate space for the player. So to do that, we can simply use a function called toLocal. Very simple. We don't really need to get, mathematical with this. We can just use this function and it's done. Just like that. And you can control click and, read its description and stuff if you really want to. Now we can say, let's say, what did we call it? Laser line points, which is this guy right here, which is just like an array of vector 2's. And since it's an array, we can get the second element here, the one that we want to change, by saying brackets 1. Because the first element is 0, the second element is 1, the index. So that's how we can get that. And then we can set that to be localized collision point. Okay. Now, as you can see, we basically have the effect working. If we get closer, farther away, you can see that it's working. Same with the box here. As you can see, the only problem is when we're not pointing to anything, it's just using like the last position or something else that's left in there. To fix that, we can simply say else. If the raycast isn't colliding anymore, we'll simply set this to be vector 2, 1000 by 0, the default value we had. Now it should be fixed. And as you can see, it is. Yeah. Okay, it's working perfectly. So yeah, very important to set this to be local, otherwise you're just gonna get like a crazy laser that's not accurate at all, which is not what we want. So that's the basic effect, and there's a lot of things we can do with this. First of all, obviously we can make it look nicer, which we're going to do a little bit now. And we can also make the code a little bit more optimized as well. At the moment, we're setting this variable all the time over and over and over again in the process, which is probably not a good idea. So in this case, you should probably just set this once and that's it, because it's never going to change if the raycast isn't colliding. And for this case, we should only set it if the laser actually moved, because if it hasn't moved, there's no reason to set the same, collision point over and over again to it, basically. Yeah, I'm not going to do those just now because, I don't want to make this tutorial 60 minutes long. So it's just something for you to do. Maybe after the tutorial, you can give that a go if you want to. So now let's try to make it look a little bit nicer. So there's a couple of things we can do to do that. The first one is using some particle effects. We would basically create some at the start here to signify that the laser is being emitted. And then we would put some at the end to signify the laser is hitting something. And then in the middle, we would also, emit some particles to make it look nice, but not really going to get into that. That can be a separate tutorial on its own because it's going to take some work to set that up. It's going to be dynamic from the script as well. So if you want to see that, leave a comment and I'll try to make a video to add some particle effects to this laser. But what I want to do in this one is I want to use an animation to animate the width of the laser when we turn it on, so that we have something like a nice looking effect with it. So first of all, we're going to implement turning the laser on and off, and then we're going to create the animation. So first of all, let's create an input action, and let's just call this toggle laser. and we'll give this the right mouse button. And then in the player, let's see. Up here we can just say if input is action just pressed, toggle laser. Then we can create a laser on variable, which is going to be a boolean. Let's set it to be false at the start. And then we'll just say in the toggle here, we'll set it to be the opposite of whatever it was. So if it was true, we're going to set it to be false. If it was false, we'll set it to be true. Toggling it basically. And then we'll say laser line visible equals laser on. And then we can control the visibility of the laser. And when we play at the start, it's not gonna work because it should be, turned off at the start. But then if you start toggling it, it's gonna work after that. Okay, it's working. And now simply at the start in ready, we simply need to say, we need to do the same thing again, basically. And we can turn this into a function, but for now, I'm just gonna leave it like this. And now when we start, the laser will be off. And when I press the right mouse button, it's going to turn on. And adding a sound effect to this will also make it, much, much nicer. Just like we did with the, the gun and the enemy hurt effect, which was in a different tutorial. If you want to take a look at that, take a look at the description. Okay, so we have the toggling. Next up, we're going to simply animate the width. Let's create an animation player here. Let's create a new animation. We'll just call this laser, turn laser on. And this is going to be very short, like 0.2 seconds or something like that. Let's take a look at it, and we'll set the snap to be 0.01 so that we can really surgically move the needle here, just like that. And then at the start, we're simply going to click on the laser node. We're going to set the width to be 0, key this, and then after 0.3, 0.4, after this much, whatever that is, we'll set this to be something larger than what we want it to be, like 4 pixel. Key that, and at the end, we'll bring it back down to 2 pixels and key that as well, which is going to look like this. It's kind of difficult to see it, but it's gonna look good. And we also created some reset tracks. What's the width here? For the reset, let's just make it 2 and key that, that's fine. And we'll go back into turn laser on. Okay. So we have the animation. Let's play it. Let's create a reference. And we are going to play it when we toggle it. So if it's visible, we'll say animation player, play, turn laser on. Let's see what that looks like. As you can see, it's not that huge of an effect, but it does add just a little bit of spice. And maybe actually we can make it a little bit more dramatic with this keyframe right here. With the width, we can make it 6 to really, and key that, of course, don't forget, really emphasize that this is being turned on, just like that. Yeah. Okay, it's starting to look nicer. Obviously, it's not amazing, but it's a start. And like I said, you can animate all of these things, like the border, you can add a border, you can do stuff with the cap, you can do stuff with the fill here. You can play You can add like a curve to the width. You can do all sorts of things. But yeah, that's how to create the animation, how to toggle it, how to create the line, and how to make it dynamic using the raycast's collision point function. That's going to be it. If you do want to see me adding particle effects to this and making it look really, really nice, leave a comment and I'll try to create one more tutorial for the to laser effect to do all of that. But besides that, if you have any other feedback, anything you want me to do in terms of a tutorial, a video, leave that as a comment as well. If you like this type of tutorials, make sure to subscribe and also at the same time join my email list to get updated on the work that I do. So there's a link for those in the description. So take a look and take care. I'll see you in the next video.